So as you can see, we have the first two sections here crossed off, although I should not have crossed off this part right here, so I'm going to try to save it. Right here we have if an object is thrown up into the air, its position function is given by this right here, where t is measured in seconds, s of t in feet. V sub 0 represents the initial velocity. Of course, the trash men are outside right now. So v sub 0 is the initial velocity, velocity at time 0, and s of 0 is the initial position at time 0. So let me rewrite that down here. In other words, if a particle is thrown up into the air, the position is negative 16, that's the gravity constant, multiplied by t squared. And we've done this before. In fact, we just did this. Add to that v sub 0 times t plus s of 0. And again, v sub 0 is the initial velocity and s of 0 is the initial position, okay, or the initial height. Okay, and so let's go ahead and look at this box right here. An object is thrown upward, subject to gravity. We're usually interested in just really a couple things. How high the particle goes, so how high the particle reaches, and how fast it's going at a certain time, or in this case when it impacts the ground or the water. So those are a couple things that we want to figure out. Well, if we want to know how high it goes, what's the velocity at its maximum height? So if you think about it, there's this particle that gets thrown up into the air, it reaches the maximum height, and then it comes back down. So initially it goes up, and then it comes back down, and it hits the water or the ground. Well, on the way up, the velocity is positive. On the way down, the velocity is negative. So in between, at its maximum height, the velocity must be equal to 0. Okay, and so to find the maximum height, you set velocity equal to 0, solve for t, and then figure out what the position is at that time. Okay, so always, everywhere along the way, we have a position at a certain time, and if we can figure out what time the velocity is 0, we plug that into the position, and we'd be able to figure out the position when velocity is 0, and that would give us the maximum height. So let's go ahead and do that first, and we'll do A and B down here, and then we'll get over there to the other part. The velocity and speed at t equals 3 and t equals 5. Well, first of all, the projectile is launched vertically upward with an initial velocity of 112 feet per second. That's our v sub 0. And from the ground level, that means that s of 0 is equal to 0. Okay, so v sub 0 then is 112 feet per second. S of 0 is 0. So we're going to write our position function. Position function is always the negative 16t squared, and it's 9.8 if by chance, or sorry, negative 4.9 if by chance we're dealing with meters per second. But in this case it's feet per second. So negative 16t squared plus v sub 0t plus s of 0. And so we just defined v sub 0 as being 112 and s of 0 is 0. So we have our position function, and from that we need our velocity function, and the velocity again is the rate of change of the position. And the rate of change of the position is the derivative of the position. So the derivative of negative 16t squared is negative 32t, and then the derivative of 112t is just 112. Okay, and we're being asked to find v of 3, the velocity at time 3, and the velocity at time 3 then would be negative 32 multiplied by 3 plus 112, and that's negative 96 plus 112, which would be 16. And well, let's make sure we always, when we're dealing with real life kind of situations where we're applying the derivatives that we're learning, let's make sure we include units of measure. This would be feet per second. Okay. Now the velocity at time 5 then would be negative 32 times 5 plus 112. The negative 32 times 5 is negative 160 plus 112. And what's that? Negative 48. Negative 48 feet per second. Okay, so those are the first two answers, and let me put those in a box. So v of 3 is 16 feet per second, and v of 5 would be negative 48 feet per second. So from that information, you should be able to determine and understand that in between t equals 3 and t equals 5, the object has hit the highest point, okay? Because v of 3 being positive means that on the way up, it's on the way up, and then v of 5 means that being negative means that the object is on its way back down. Okay, and so how high will the particle rise? Let's see here. How high will the projectile, I should say, rise? Well, we know that if the v equals 0, that's when it hits the highest point. When v, meaning negative 32t plus 112 is equal to 0. So v of t, when v of 0, when this, okay, so we need to solve this for t. 32t equals 112, and t equals 112 over 32. Well, 16 goes into 112 7 times, and 16 goes into 32 2 times, and so we get t equals 7/2 seconds. That's 3.5 seconds. Okay, well, that's what we said. We said v of 3 is positive, v of 5 is negative, so therefore in between t equals 3 and t equals 5, the v is going to have to be equal to 0. And that's exactly what happened. And so at 3.5 second mark, let's use our diagram, at 3.5 second mark, t equals, or let's put 7/2 seconds. At 7/2 seconds, we reach our maximum height. Well, this is asking us, how high will the projectile rise? Well, how high, that's position. What will the position be when t equals 7/2? Well, what's the position when velocity is 0? The position when the velocity is 0 is the position at 7/2, and we already have the position function. That's negative 16 times t squared, so 7/2 squared, and then plus our 112 multiplied by our 7/2, and then plus our 0, we already know that's plus our initial position, that's 0. Well, negative 16 times 7/2 squared, that's negative 16 times 49 over 4, plus, let's see, 56 times 7, because 2 goes into 112 56 times, 4 goes into 16 4 times, and so we get negative 198 plus 56, 43, 92. What in the world is that? Position is 7 times 56. Is that what I got? Oh, I did this over here. Position at 3/2. Oh, what did I do? 3/2 seconds. What in the world? Where did my math go wrong? It should be 7/2 seconds, right? And so 7 times 50 is 350, 392. So 392 plus, let's see here, negative 4 times 49, well, that would be 196, right? Negative 196. What's negative 196 plus 392? 196, and then we have 8 here, 12, 6, 2, 18, 9, and we have 196. Yeah. So 196 feet high is how high it went. 196 feet. Sorry for the delay there. I had a little brain freeze there. Anyway, 196 feet high, so S of 7/2 is 196 feet, and that's how high it went. Let's see if I can finish this last part. To kind of leading up to the speed of the projectile when it hits the ground, we want to first think about, when an object hits the ground, what is its final position? Well, the position at time t would be equal to 0. We just want to know, well, if we set S of t equal to 0, we want to know what the t is, and if we want to know the velocity of the object when it hits the ground, then we want to find the velocity at that time. Okay? So the speed of the projectile when it hits the ground, first thing we want to do is set our position function equal to 0. And we're going to factor out a negative 16t, and we're going to get t plus, t minus 7. 7 times 16 is 112, so t minus 7 is equal to 0. And so we know that when t equals 0, the object is already on the ground. That's where we started. Okay, but when t equals 7, that's also when the object is on the ground. And so at the 7-second mark, and that makes sense because 7 halves is right up on top. So 3.5 seconds to get to the top, 3.5 seconds to get down to the bottom. Okay, and so at t equals 7, what's the velocity? Well, we need to plug in 7 into the velocity function. The velocity at 7 would be negative 32 times 7 plus 112. Okay, and negative 32 times 7 would be negative 224, okay, plus 112. That equals negative 112 feet per second. So the velocity is negative 112 feet per second. Interestingly enough, the initial velocity was positive 112 feet per second. So we can see from what we just did that when you launch an object up into the air at an initial velocity, takes 3.5, well, this particular one took 3.5 seconds to go up. So no matter how much time it takes to go up, it'll take not only that much time to come back down, but it'll also hit the ground with the same velocity as as the velocity that you launch that object with. And this is why we don't shoot bullets into the air, because if you shoot a bullet into the air, then the velocity that that bullet hits the ground with is the same velocity as it left the gun with. Okay, that's why you don't shoot a bullet in the air, because it's going to hit the same speed as it left the gun, which is really fast, in case you were wondering. Anyway, this didn't ask for velocity, did it? It asked for the speed. So the speed at time 7 is equal to the absolute value of the velocity at time 7, which is the absolute value of negative 112, which is 112 feet per second. And that right there is the end of page 77. And we do have more, don't we? I might leave that. I don't know. I'll decide what I want to do with that. That's your third video. I have to give you 4. But I might. Alright. See you in the next video, possibly.